Hello everyone, welcome to the part 3 of the current electricity. Very important MCQs from NEET. Previous year question, and we will solve some new question from this chapter which is very important for your exam. So look at this question. Two resistors of resistance 100 ohm and 200 ohm are connected in parallel in electrical circuit. The ratio of the thermal energy developed in this both the resistance we have to find out. Okay. So that means we have to find out the ratio of the heat. So one formula we have, H is equal to V into I into T. Okay. So here the time is same, so T is constant in this case. And the another formula to find out heat is nothing but H is equal to I square into R. Okay. So if we take the ratio, it will become H1 upon H2 is equal to I1 square upon I1 square R1 into T will get cancelled, so I2 square R2. Okay. But current is not given, so we'll use the current as in terms of ratio. So how the current and resistance are related? I is related to 1 by R. That means if you want to write down I1 upon I2, which is same as R2 upon R1. So R2 is 200, R1 is 100, so 200 by 100, that is 2. So if we do the cross multiplication, then I1 is nothing but 2 times I2. Now we'll put this value in this equation number 1. Then H1 upon H2 become I1 square, so I1 is 2 times I2 the whole square upon into R1, which is 100, divided by I2 square divided by R2 is 200. So this 100 to the 200, and if we do the square here, so it will become 4I2 square divided by I2 square multiplied by 2. So this I2 square will get cancelled, 2 to the 4. So the ratio of H1 upon H2 is nothing but 2. Means the ratio is 2:1. So the correct answer is D, 2:1. Okay. Look at the next question. Look at this next question. This is also previous year NEET question. This diagram is given, and it is given that G does not show any deflection. Okay, here there is no deflection. That means the current is 0. Current is 0 here. No deflection. So the question is the value of R is. We have to find out this value of R. Okay. So look at this diagram. We'll let's say give the direction. So current is, let's say, from this branch it is going I. Okay. Then there is no current in this branch because there is no deflection, so current is 0 in this branch, so the full current is going here, I. Okay. So let's apply the Kirchhoff's rule here. Before applying, let's give the sign. This is, let's say, minus, plus, minus, plus, then plus, minus. Here also minus, plus. So if you apply the Kirchhoff's rule, second rule, for this A, B, C, D, E, F, A, okay, in this full loop. So here the current is I and resistance is 400 with minus sign, so minus 400 I. After that, from here to here, minus 2. Then after that, we are reaching the plus 10 end. So plus 10 is equal to 0. So minus 400 I minus 2 plus 10 is equal to 0. So minus 2 plus 10 is nothing but plus 8. If we take this plus 8 that side, so minus 8, and minus 400 will go in the denominator, so minus minus get cancelled, so 8 upon 400, which is nothing but 1 by 50. So the current is I is equal to 1 by 50 ampere in this full. Now let's apply the Kirchhoff's rule in the second branch, this one, A, B, E, F. So in this branch, again the same thing. Here the current I and resistance is 400, so minus 400 I. Then here, now we are going in this branch BE. So current is I and the resistance is minus R. So minus I into R, and we are end up with positive 10 between. So plus 10. If we take this plus 10 this side, become minus 10. So if we solve this equation, minus 400 I minus IR is equal to minus 10. Okay. And we know the value of the current we got, that is 1 by 50. So that we will substitute here. So minus 400 into 1 by 50 minus 1 by 50 into R is equal to minus 10. So here this 0 and 0 will get cancelled. 5 8 is 40. So minus 8 minus R upon 50 is equal to minus 10. So if we take this minus 8, this side become plus 8. So minus 10 plus 8. So minus R upon 50 is equal to minus 10 plus 8, which is nothing but minus 2. So minus R upon, if we multiply this 50 here, so it become minus 100. So if we cancel out the minus sign, so the value of R is nothing but 100 ohm. So our correct answer is for this question is 100 ohm. The idea is you have to apply the Kirchhoff's rule in this branch and then in this branch. So you will get the resistance. You can do by doing the short trick also. Here there is no current, so the voltage is same for this point and this point. Okay. Look at the next question. This is also the previous year NEET question. Here also we'll apply the Kirchhoff's second rule. So let's say current is going in this direction. So here minus I, minus, plus, plus, minus, minus, plus, and then minus, plus. So current, let's say going it is high. So current is I and here resistance is negative 2. So minus 2I. Then plus 10. After that this minus 5. And then minus 1I. Then it will go here, and in this branch minus plus. So again minus 7 times I is equal to 0. So if we solve this equation, we will get the value of the current. So minus 2I minus 1I minus 7I. So it become minus 10I. And 10 minus 5, which is nothing but plus 5, is equal to 0. If we take this plus 5 that side, so minus 10I is equal to negative 5. So I is equal to minus 5 upon minus 10, which is nothing but 1 by 2. So 1 by 2 is nothing but 0.5 ampere. So current flowing in this circuit is nothing but 0.5. So we know that okay, so 0.5 is there in only one option. So our correct answer is C, 0.5 ampere from A, B through E. Okay. Look at the next question. Look at this next question. The resistance of platinum wire is 0 at 0 degrees Celsius is 2 ohm and 6.8 ohm at 80 degrees Celsius. The question is find the temperature coefficient of the resistance. So we have the formula resistance of final temperature minus is equal to initial temperature bracket 1 minus alpha. So this alpha is nothing but temperature coefficient. So we have to find out that alpha. Okay. So RT is equal to R naught bracket 1 plus alpha into T2 minus T1. So let's find out the temperature difference first. So how the starting temperature is 0 degree and final temperature is 80 degree. So the difference is 80 minus 0, which is nothing but 80. So 80 into alpha plus 1. And if we take this R naught in the denominator, so it is equal to 6.8 divided by 2. So we have to find out this alpha. So this 1 will come here. So 6.8 upon 2, it is nothing but 3.4. Then if we take minus 1 is equal to 80 alpha. So we required this alpha, so this 80 will go in the denominator. So this 3.4 minus 1, which is nothing but 2.4. This 80 will go in the denominator, so 2.4 by 80 is equal to alpha. Okay. So if you remove the decimal point, so it will become 24 by 10 and into 80 is there as it is equal to alpha. Okay. So if we write this 0 here, so we can write down like this 24 upon 100 into 8. Okay, so 8 3s are 24, so 3 is the number, and 100 means 10 raised to 2. If we take in the numerator, it becomes 10 raised to minus 2. So the correct answer is 3 multiplied by 10 raised to minus 2, which is option number D. Look at the next question. Okay, this is very interesting question. 10 resistors, each of resistance R, are connected in series to a battery of EMF E. Okay, so number of resistance are 10 and it is connected in series. So in series connection, what is the net resistance when identical resistance are there? Then n times r. Okay, so it is nothing but 10 times r is r, so it is 10r. After that, with negligible internal resistance, then those are connected in parallel to the same battery. So in parallel connection, in case of identical resistance, the formula is r upon n, which is nothing but r upon 10. The current is increased n times, then the value of n is. Okay, so for this question we have one short trick. So whenever n identical resistance, okay, we are connected in parallel series first, and this series connection we are shifting to parallel, then current is increasing. Okay, current in parallel is increasing n square times current in series connection. Okay. So this is the result. Current is increased n square times current in series. So what is n here? N is nothing but 10 resistance. So we have to just do the square. So 10 square, which is nothing but 100. So our correct answer is option number C. The current increased 100 times in the parallel connection. This is a short method, and otherwise you can do by using the formulas. So in that, by using the formula also you will get the same answer, 100. Okay. Look at the next question. Okay, before going the second question, if you want the solution of this first method, I will give you. So to find out current, we have the formula I is equal to, here battery is E, so E by, so when it is connected in series, the net resistance is NR, so which is equal to E upon 10R. So this is the current in series. Then if you find out the current in parallel, so E upon the net resistance is 10 upon R. Okay, so R by 10, so R and upon 10 will go in the numerator, so 10 times E by R. Okay, so it is given the current is increased n times in parallel connection. So IP is equal to n times in n times IS. Okay, so if you apply the formula, current in parallel, which is 10 E upon R, is equal to n times current in series, which is E upon 10R. So from both the side, E and R will get cancelled, and if we do this cross multiplication, so 10 into 10 become 100 is equal to n. Okay, so this is another way of showing it is 100. Otherwise, whenever n identical resistance, we are shifting from the series to parallel combination, okay, across the same potential, then current increased n square times the series connection. Okay, this is the result. Look at the next question. Look at this next amazing question. A wire of length L of resistance 100 ohm is divided into 10 equal parts. The first 5 parts are connected in series, while the next 5 parts are connected in parallel. So the combination are given connected in series, then resistance of the final combination is. Okay, so the first, whenever let's say this L length resistance is given, the length is L, so if we cut into n equal parts, okay, if we are cut into n equal parts, then the resistance of each part, okay, resistance of each part is nothing but R upon n, total resistance upon total how many parts we have done. So your total resistance is 100 ohm of the wire of length L, so we have divided into 10 equal parts, so the resistance of each part will be 100 by 10, which is 10 ohm. Okay, so every part has a resistance 10 ohm. Now out of this 10 resistance, 5 resistance we have connected in series. Okay, 5 resistance, let's say R1, 1, 2, 3, 4, 5. 5 we have connected in series, and the remaining 5 we have connected in parallel. So every resistance has the 10 ohm. The value of the resistance of each is 10 ohm. So in series connection, what is the net resistance? N times R. So total 5 resistors are there, and all the 5 are identical, so 5 times 10, which is equal to 50 ohm. And the remaining 5 resistance, which is also value of 10 ohm. that we have connected in parallel. So in parallel connection, what is the net resistance? R upon N. So R is 10, and total how many resistance are there? Identical, 5. So 10 by 5, which is nothing but 2. Okay, so this is the answer of parallel connection. This is the answer of series connection. After that, it is given that this both the combination, okay, this series combination of 5 part and parallel combination of 5 part, this again connected in series. That means this 50 ohm resistance and this 2 ohm resistance are connected in series. So in the series connection, we have to just add up. So 50 plus 2, which is nothing but 52 ohm. So correct answer is D. Okay. Look at the next question. Look at the next one. The question is, the terminal voltage of the battery whose EMF is 10 volt, internal resistance, that means small r, which is 1 ohm, connected through external resistance, which is capital R, which is equal to 4 ohm. Okay, so the similar type of question was come in the 2026 exam also. We have to find out the terminal voltage. Okay, so we have the formula for that. P is equal to E minus IR. So if you apply this simple formula, E minus IR, smaller. So E is given to be 10 volt minus current. Okay, current is not given, so we have to find out the current first. So current formula is nothing but E by R. So 10 upon total resistance is what here? This 4 ohm is external and this 1 ohm is internal. Okay, so total is 5 ohm in series. So 10 by 5, so current is 2 ampere. So I is 2 and internal resistance, which is given to be 1. So 10 minus 2 into 1, that is 2, which is equal to 8. Okay, so terminal voltage is nothing but 8 volt for this question. Look at the next one.